We don't need to keep track of time to listen. Our agenda time is pretty open. Yes.
Oh yeah, and the other one's right there. Thank you.
Why are the slides
about the maximum. Well, that's
the message which they do that.
Yeah, the process of
Setting those
You're trying to get an E with an accent? Or you're trying to get an E with an accent? Is that what you're looking for?
Yeah, I was getting Eric with the accent, so I just copied him on the agenda list.
Hopefully we don't break.
I do this all the time.
Oh, nice. I'll just give it a few more until 4 and then.
We still don't have a note taker.
yeah. Well, so
No, it doesn't say that. That's what we're trying to solve.
that's good.
Your point was that other than that.
Well, I think it fixed the queue.
Tim, yeah.
That's fine. I'm going to that's kind of a moving target.
Tuesday morning. Yeah, that's exactly
The start.
The microphones are incredibly cool.
All right, please take your seats. Lorenzo, can I ask you to close the door, please? Thanks. Should we get started?
Yeah, you should.
All right. Good afternoon, everyone. Hello. And welcome to DNS Service Discovery. This is Barbara Stark, and I'm David Skenazy, and we are about to start talking about Dnssd. Before we begin, we do not have a minute taker yet. Could someone volunteer? Thank you. We've set up the Meet Echo of the Etherpad with the agenda. And if anyone else wants to jump in and help in on that, please feel free.
And I'll be supporting there on Etherpad, so you're not alone.
And the blue sheets are going around. Please make sure you sign them. So it is Thursday afternoon. Hopefully you've seen the note well by now. This meeting is covered by the IETF note well. If you have not read it yet, please do so. It covers things such as patents and what your responsibilities are in the IETF, and also, very importantly, the code of conduct with which this meeting is going to run. So, usual reminders, anytime you talk at the mic, please state your name clearly for the minute taker. And please review the documents that happen in this working group. That way your documents will also get reviewed. And sign the blue sheets. So here are some links for people following online. Did I get it wrong? Every time. I saw your email. This is silly. More useful links for people still following online. Yeah, quick usual shout out. We have a GitHub organization for the working group, and anyone working on a draft in the working group or that wants to be in the working group is welcome to set it up there. Just talk to us and we can make it happen. Our goals for today. We're going to have an update on our currently active documents, both in terms of standardization and actual running code. And then we're going to talk about service registration and discovery relay. And we're going to fill up the rest of the allotted time with the future of this working group and the privacy efforts and where we want to go. So that's the agenda as currently stated. Would anyone like to bash the agenda? All right, Stuart. Please stand on the pink X, otherwise the Acme anvil will miss you.
This is an update on our push notifications document. We discussed this at the last IETF meeting. We're on version 19. We had working group last call to review that. That went smoothly. David requested publication. We had ISG review. Last call, we got some feedback. We made some updates, and that's what I'm going to give a quick overview of right.
Huh. Escape maybe on the Chromebook? That's weird.
No, that's an extra little thingy popping.
Well, but,
no, we need to fix. We need to push a button. Yeah, there.
Press escape.
Yeah.
Thanks.
Yeah, it was not a meat echo problem, it was a projector problem.
RAM is cheap.
Cycle them to double check. Yeah, cool.
Okay, so this is the timeline. I don't need to read it out. You can all read. Here's the summary of what's new. We realized that the whole document focuses on the mechanisms of push notification, which is fine. What it neglected to mention is the reality that any client using this, if push notification is not supported, is going to fall back to using a regular DNS query to get the same answer. That's kind of obvious, but it didn't say that. So we added some text that says, when you do that, you shouldn't poll more frequently than once every 15 minutes. And that's just to give some guidance so that we don't end up with ridiculous burden on servers. There was also a mismatch in the document. Late in the process, the DNS stateful operation, RFC, added some explicit text about when TLS early data is permitted and when it's not, because there can be risks with replay. So you only want to use it for idempotent operations. And there is a requirement in DSO that you state which DSO operations are allowed in early data. and we had not updated the push draft to include that required language. So we did a bit of thinking, and we figured that doing the subscribe is not something that will cause harm if it's duplicated, and the performance benefits of saving a round trip may well be worthwhile. So we put in the required text saying we've considered the security implications and this is fine with TLS early data. So those two are easy. The big topic was, I hope, a storm in a teacup, but it turned into a long email thread. And what happened here was we had copied text from the DSO document this is based on, where in many places it says, if there's a fatal error, you should immediately abort the connection with a TCP reset or equivalent for other protocols. And in DSO, as in this document, we may be a victim of trying to be too thorough in stating all of the rare corner cases that should never happen, but if they do happen, what you should do about them. Martin Thompson has written a draft recently. The title is something Postel was wrong, or something to that effect.
It's been renamed to something less controversial.
He was mostly right about many things, but I happen to agree with Martin Thompson on this one, that being liberal with what you accept, particularly for the first implementation of a thing, anything you're liberal about, other buggy implementations will probably accidentally do, and if you accept it, then all those bugs become entrenched, and then you have an ecosystem of lots of buggy code. I think for the first implementation of anything, you actually have a responsibility to be strict and reject invalid input, because in effect, your implementation is the conformance test. The IETF doesn't have conformance tests and certifications that have to be passed to get to use the IETF logo on your product. So we have very little enforcement of our protocol. In effect, the deployed implementations are the conformance test, because somebody coming along to make an implementation is going to test it with yours. And if it works, they'll ship it. And if it fails, they'll debug it. So early in the game, I think it's really important to enforce all the things you want to, because anything you don't enforce, you don't get to enforce later. So with that spirit in mind, in many cases, the document says, if you do something completely bogus, then the other end is going to reset the connection. So if a client connects to a server and then sends it a response, that makes no sense. Tear down the connection. Don't even bother with an error code, because that is something that the programmer is going to debug by looking at a packet trace. This is not a runtime error that occurs in the field. This is just a gross programming error, and you fix the bug. So there are many cases like that that I think a lot of specs wouldn't even mention. We were trying to be really thorough, and we put this text in. Robert Sparks pointed out entirely correctly that DSO is general and could in principle run over any transport. For push notifications, we have specified for now only TLS over TCP. Running it over something else would be a future document to update this. So Robert said, since it's only for TLS over TCP, you can remove the equivalent for other protocols, because there aren't any. Oh, good point. Okay, we'll delete that text. That's easy. In the ensuing discussion, David helpfully said, well, if you're using TLS, you should send a close notify instead of reset, which for a graceful close is true. But here we're talking about really fatal error conditions that should never appear except in the development process. And hence, a long discussion went on the mailing list, and a lot of off-mailing list discussion too.
I just want to confirm that, yes, I didn't have the full context in that comment. As a result of this, which was quite valuable, I went back and did a pretty thorough review of all the places in the document where it talks about a reset and worked out what the context is. There was some discussion that instead of tearing down the connection, the server could use the DSO retry delay operation to tell the client, you are grossly buggy,
go away and don't talk to me for half an hour. There was some debate about whether we can expect a grossly buggy client. The kind of client that connects to you and immediately sends you a response may not process the rest of the protocol as well. So that is a question that we can't answer. It's a speculation about implementations that don't exist yet that are very buggy. There was also lots of discussion about, well, the client can enforce the delay, and that turns out not to be as easy as it sounds, because you can't tell. Two successive connections could be from the same client, or they could be from different clients behind the same NAT gateway. So, or with IPv6, they could be different privacy addresses on the same device or different devices. The whole point of privacy addresses is to obscure the identity of the client. So if the server can tell it's the same client twice, in a sense, privacy addresses aren't working. So it's hard for the server to enforce that. I also, when I looked through, I found that out of the 12 cases, 7 of them are the client tearing down the connection because the server did something bogus. So clearly in the case of the client tearing down the connection, it doesn't need to tell the server, don't call me back, because servers are not going to connect to clients. So the end result of this is, for the 7 bogus server messages where the client just gives up on the connection and either tries a different server or waits, those are now back to saying send a reset. 5 of them are bogus things the client does. 3 of those are the client sending responses to the server, which is so bizarre that if you look in most specs, if you look in RFC 1035, there is no language about what to do if a client connects to you and then sends you a response. It's just so silly they don't mention it. We do mention it, and we say if a client does that, you just give up on the client. Sending a FIN then puts the server in close wait state while it's waiting for the FIN to be acknowledged. And if there's a client looping, doing bad things, that can end up to being quite a resource burden on the server, which is exactly why web servers do not send a FIN, because they don't want to have the burden of maintaining that state. So the client sending a response is bogus. The client sending a push message is equally bogus, because that's a notification which should go the other way. And the last one here is the only one that I think is somewhat debatable, and that is if the client sends 2 identical subscribe requests. And I want to explain the reasoning why we had the wording like that. Because, as I said, we don't have conformance testing in the IETF, my fear is that some developer might get lazy, they're busy, they've got a deadline, and they make an implementation that does not check for duplicates. And you could easily imagine, oh, we'll fix that later, that's not important, right? That'll be a version 2 feature. If we don't want that to happen, we have to have some safeguard in place that will cause that developer to say, hang on, no, I can't leave this for version 2 because my client's going to break. So that is the reason for this, is to be unforgiving about our requirement that clients should suppress duplicates. We do not want a client that ends up sending 100 identical requests to a server because of a bug. And if that happens, the server should protect itself. So that is the summary of the changes. I would welcome any feedback. I would also welcome complete silence, because that would indicate there's no disagreement. And of course, we won't make any final decisions here in the room. You can also comment on the mailing list. Okay, well, I'm really happy that that's uncontroversial, which it should be at this stage in the process. We will go ahead with publication of that. I also saw on David's agenda, it said hackathon implementation report. I don't have a slide for that, but I can verbally tell you, Ted and Barbara and I had a productive couple of days sitting together working at the hackathon. The code we're working on is on the hackathon GitHub repository. If you go to github.org/IETF-hackathon, you'll find the MDNS responder repository there. Ted and I have been working on code. We have running code that you can run on Mac or Linux. We've also been building it for OpenWRT. We have these neat little GL iNet home gateways about the size of packet playing cards that run OpenWRT. We have pre-built packages for that, so you can try it out. We did demos at the hackathon, and we also went to the hack demo happy hour on Monday and had a table set up there showing it to people. You can try this yourself at home, because I'm a firm believer in living on software. That's how you find when it doesn't work. I have now switched to using one of these GLINet routers as my default home gateway. My Mac and my iPhone are set to connect to that by default whenever I come home, so I'm normally on that network without thinking about it. And that GLINet home gateway is running the Discovery proxy. It is not forwarding multicast. It is in the normal configuration. It's running DHCP. It's running NAT. There's isolation between the LAN port and the WAN port. But with the Discovery proxy, all the stuff I do on my Mac and my phone, printing, scanning, anything else that's using Bonjour Discovery, it just works. And anything that doesn't work, I find it, and then we work on fixing the bugs. So,
Can I just interrupt? And Ted, I think we said that Friday morning, we're going to start plugging things together. And if anybody wants to build a load and bring a router and plug it together, we're going to be meeting in the Code Lounge at 10. Was that what we said? Thereabouts-ish. And try and plug things together. So you're all welcome to help plug.
Michael Richardson, Stewart. So if I understood what you just described, that you have plugged this device, wired WAN port into your existing home network, creating 2 layers of router.
yes.
Okay. And on the wireless or maybe the wired port, you now can see the devices which are on your original network.
What is nominally labeled the WAN port
Yes.
on the GLINet is plugged into my existing home network. Correct.
Just wanted to clarify that you didn't. I was going to say, well, what's the utility if you've just replaced your home router with one of these? There, it's all on the LAN side. So what does it mean? I got you now.
Thanks for the clarifying question. Yes, the utility is twofold. One, for me and Ted working on this code, the utility is testing it on a daily basis. In terms of why anybody else would do this, looking forward to the broader picture of why we're doing this work at all, one benefit I get of that compared to how my network was is my client devices, my laptop and my phone, are doing all their discovery with unicast. So on the Wi-Fi link, where multicast is slow and inefficient and unreliable because it's not acknowledged and very wasteful of shared spectrum because it's sent so slowly, I'm now not flooding lots of multicast traffic onto that Wi-Fi. I'm keeping the Wi-Fi clean, doing unicast to the gateway. And then on the gigabit Ethernet that can handle tons of multicast, no trouble, I'm still using legacy multicast discovery for the devices on that Ethernet. But the client devices on Wi-Fi are not being bombarded with lots of multicast traffic they don't care about. All right, thank you.
Thanks.
Hi, I'm Ted Lemon. I've been working with Stuart on all this fun stuff. So one thing about the Plug Fest on Friday is that if you want to come with your OpenWRT device, you probably want to do a build before then because it takes longer than 2 hours to do a build. So there's code. There's a URL at the end of this slide deck that points you to the repository, and you would want to download our fork of OpenWRT and build that rather than attempting to do something more adventurous at the Plugfest. And if you have any issues with that, that's my email address, and I'm happy to answer questions. So I actually have, well, I'll just on the introductory slide here briefly, I have 3 things to talk about, various different bits of work that we've been working on over the course of the last couple of years to discovery proxy, discovery relay, and service registration protocol. So I'll talk about discovery proxy first. So the discovery proxy, I assume most folks here know what a discovery proxy is, but just to recap, a discovery proxy is a device that receives queries using DNS on port 53 and asks questions to answer those queries by using multicast DNS. And so this is an important goal for a variety of use cases. The case that dragged me into it was HomeNet. And so we've implemented a nice fully featured Dnssd discovery proxy. It actually uses MDNS responder to do both DNS lookups and MDNS lookups. And then, so when you send it a question on port 53, it goes out and does whatever it needs to do to come up with the answer using MDNS responder, which is Apple's open source DNS, all singing, all dancing stub resolver. So we've implemented listening on port 53 for DNS queries, listening on port 853 for DNS push connections. So it's a full working implementation of DNS push over TLS. And it also does something that I wanted for HomeNet, and it does it accidentally. Like, I didn't actually plan it out this way. I just planned on writing a discovery proxy and then figuring out a way to wedge a DNS server in alongside it. But it turns out that since MDNS responder acts as a stub resolver for DNS and MDNS, that I could just use that for both authoritative service and recursive service. And so this basically is a swap and replacement for DNS mask, except that it now does proxy as well. So it's pretty sweet, and you can try it out anytime you want. It runs on Mac OS. It probably run on BSD, but I haven't tried it. It definitely runs on Linux. And as far as things that can do queries against it, pretty much anything out there that does DNS service discovery can use it. However, we also have implementation on various new Apple devices that will do DNS push. So you get, not only do you get just regular old service discovery, but you also notice when new things show up immediately rather than having to wait 15 minutes for for a retry. And the code for that is in the open source MDNS responder distribution that's on the GitHub. However, the support for DNS push needs a little bit more TLS glue to work on sort of the POSIX side of things. That stuff's all working on a Mac OS X, but it uses the network framework on Mac OS rather than using sockets. And so that there's a little bit of additional work left to do there. So before I go on to the next thing, does anybody have any comments or questions about this? Sounds like no. Okay, so the next thing is Discovery Relay. This is actually kind of old news, but I just wanted to mention it for completeness. We did a Discovery Relay implementation kind of last year. The purpose of the Discovery Relay is basically to do something very much like what DHCP Relay does, to provide a really stupid thing that you don't have to update all the time when you add features that can sit in your router or whatever, and a full service MDNS resolver can contact it and do MDNS through it to a link that it's not connected to. So some folks have suggested that you could do this with a layer 2 tunneling program or protocol or something like that, and that's very true. And if you have that available to you, you really don't need this. But it does seem like a useful feature for a fair number of use cases. It takes advantage of IP routing end to end, and it doesn't require any special filtering to avoid having it open up a bridge to services that you don't want to bridge. So it seems like a valuable thing. It's we haven't really talked about it in the working group for a while in any detail. There does seem to be some interest from some router vendors. I don't know how serious it is. It would be nice if we could get to publication. But it really depends on whether the working group is actually interested in reviewing the document. If not, probably try sending it through the ISE. I'm not really inclined to ask the group here to tell me whether they love this thing or not, because you may or may not have read it. It probably makes the most sense to just talk about this on the mailing list, but I'm bringing it up here so that when you see the message on the mailing list, you'll know what the context is. So the implementation, as I said, we did it about a year ago. It's on the Hackathon GitHub repo, but it's on an outdated branch. I'm in the process of modernizing it to use the new code that I've written. My hope is that that code will be available for you to try out if you want to before Singapore. Comments or questions? Uh-oh.
My name is Stuart Cheshire. I know you said you're not asking for comments on this, but I feel I want to share my opinion with everybody. And as co-author on this, clearly I'm biased, but I think the work we've done with Discovery Proxy is very viable to put in OpenWRT for home gateways. For the enterprise market, convincing enterprise router makers to put this in is a much harder sell, and also probably not a good idea, because once it's in, it won't be updated until that router goes in the dumpster 10 years in the future. So, and for those who don't know, this was Ted's idea, and I co-authored the document with him, but it was Ted's idea, and it's kind of inspired by the BootP relay, which has been enormously successful for enterprise deployments of DHCP. I think this small, simple, focused piece of code, we have a much better chance of evangelizing this to the enterprise makers who we want to reach. Way back when this group was chartered, that was one of the goals, was to improve discovery in enterprise networks. So I definitely think we should push ahead. This work is basically done. We just need to adopt the draft, have some people review it, last call, or as you say, go the independent route. I would prefer to do it in the working group. Tom made the comment, can't you do this with VLANs? And I think we should add some text about that in the document. If you already have a setup where you have VLANs configured and trunk ports, and maybe some enterprises actually run their DHCP by having VLAN trunk ports instead of BootP relay agents, I think a paragraph or two discussing the pros and cons of when you might choose one versus the other, that's a useful addition. And then I think we're ready to publish, because we have a fairly mature document and we have fairly well-tested code.
Yep. So to comment on process here, this is adopted as a working group document. We had a working group last call already, and it failed due to lack of interest. So the issue here is that pretty much no one apart from the authors expressed interest in this work. I think Tom had some comments, but it was very sparse. And what we're asking as chairs is for people to comment, like, oh, especially like this is aimed at the enterprise market. Is there anyone making these devices that thinks this is useful? Like, you don't have to commit to like, oh, I want to deploy this, but just saying that this is useful would go a long way.
Yeah.
That's where we are. I personally, not as chair, believe that this is a good document, but if we want to forward it as a working group item, we'll need more people to speak in favor of this. So you can either do this now at the microphone or on the list, whichever you prefer.
Tim Wattenberg, just a quick comment which came to my mind when Stuart talked at the mic. So if this document is intended for enterprise vendors, then those routers or whatever it's supposed to run probably have the ability to do VLANs or something like this. So actually, I think we should, it would be interesting to hear if there are good use cases which are not covered by this. So I don't have a particular opinion about if that's a good or a bad idea, because I don't know this problem space well enough. But I think it's something to consider if we are not aiming for customer premise equipment, but for enterprise grade hardware or something like this, then the question is, can't it be solved there in other ways already?
Michael Richardson, I'm sorry that the working group last call was so silent and there's issues. Probably the people that we need, the enterprise reviewers that we need, are just not in this working group. I'm writing an email to some people that I think may care. I don't actually think the VLAN thing is terribly useful for organizations that are running many campuses in many places. They're in Canada today. You may know that there are significant issues getting VLANs out to places, and multicast traffic is significantly unwanted. It's probably, yes, they probably have VLANs. Yes, they've probably filtered multicast out. It's exactly what they don't want on their satellite links to Northwest Territories.
Right.
Okay, so this would be quite attractive for a number of things where I think service discovery is simply not happening, period. And so it may be another decade before, enterprises adopted enough such that everyone says, oh, we actually can do service to discovery in these distributed enterprises. Well, that's what we were chartered to facilitate. So, yeah, so let's try to socialize the document a little bit more, outside of I'm going to say the HomeNet-ish, provenance of some of this working group and back to that space, and perhaps we can get some. Which
working groups would you suggest?
Well, that's an interesting question, right? So EMU might be a good place to reach some people, because it's the same problem of, with 1X going over EAP to do authenticated join of the network. Well, okay, now that you've joined, what would you like? And that whole model is the same model, right? That you kick back, and we don't punt EAP messages back to the controller with a VLAN, right? We do it over radius. Same architectural thing. So that made space, and maybe just we don't as a group have those right enterprise people, but we do have some people that just, we always have this problem with the IETF. We don't really have enough enterprise representation. And enterprise operators are, of course, unicorns, right?
So Ted, are you willing to send some additional emails out to additional working groups to tell them about this work, or?
Well, I think, so what I would suggest as a way forward is get to the point where I think that everything that I need to do to the document is done, which may be a very short step. I haven't actually reviewed it in a while. Just, due diligence. And then once that's done, then try to get, I know that there are some folks from various places that would probably say yes to this, but we need to actually get them roped in. And so, but we should probably start a last call, and then I should do the roping in, because otherwise they're going to come and comment, and they won't be commenting on the last call. And then later on when we do the last call, because this did get actually quite a bit of comment at one time. But
so this, and speaking as chair and procedurally, it didn't feel like there was a whole lot of comments. I'll go back and look at the list. But if you get people to comment and say that they're interested in this work, it doesn't have to be in last call. We can consider those as last call or as statements of interest. Interest doesn't need to happen during last call.
Okay. Jan Commissar did send us a review about 6 or 8 months ago.
We'll take another look. So maybe once you have done your next round of changes, reach out to all those folks and reach out to us. And we can start another last call. That's fine. But if you get people even outside of last call to send those statements of interest to the list, those will be very valuable.
Okay.
I think it'll be fine to start another WGLC.
All right. So we'll update the document and then send a request.
Sounds good. Thank you.
Thanks. Stuart?
And I'm just going to echo the request for the people here. It would be helpful to review it. I just had a look. It's only 29 pages, so probably no more than an hour of reading. And if people have contacts at enterprise equipment vendors who are not involved with this working group, which is understandable, that for a lot of them, they wouldn't think they have an interest here. If you can send us those contacts, we can reach out to them individually. Thank you.
Tom Pusateri. The reason I brought up VLANs was because I know from experience that people or operators have taken a long time to learn how to troubleshoot BootP relays. And this is another thing they have to learn how to troubleshoot. And so it's not the same as troubleshooting a BootP relay. It's a different thing. It's a different problem. But VLANs is something they do already know how to troubleshoot. And there's two other ways I can also think of solving this, and that's IGMP proxies. And
Sorry?
Like IGMP proxy over a tunnel, over a regular tunnel, and AMT, automatic multicast tunneling.
But these are link local multicasts.
AMT, there's RFC on it, which is a way to join a multicast group over a unicast link to join multicast islands together.
And that will work for link local multicast?
Yes. So, but anyway, that doesn't solve the problem that Michael brought up about sending multicast, more multicast than you want. You would have to filter if there was multicast you didn't want.
Yeah, I mean, it's all just packets when it's going over the transit link anyway, but the problem is, you want to make sure that you're not sending anything more than you need to. And also, I mean, honestly, setting up a TCP connection to some device over there seems like it's a lighter weight problem than configuring a special tunnel and setting all of the filtering correctly and getting, it may be that the right answer to this is that we just have a document that says how you set up the tunnel and get the filtering right, but then you have a point solution that only works on certain kinds of devices. So, like, the device has to support IGMP tunneling.
Right. So the point is that there's multiple ways to solve this problem, and your document should probably compare them.
Sure. Yeah, I think that's good. Okay, so by the way, I just wanted to point out, in case there's confusion, remember that discovery relay and discovery proxy are two different things. Discovery proxy is the smart thing that actually does multicast resolution on the local wire, and discovery relay is the dumb thing that just relays the packets and lets the aggregation and resolution stuff happen on a smart server in your machine room or wherever. So, all right, so moving right along. So the other document that I've been working on is the Service Registration Protocol document. Tom very kindly did a review of the SRP document a couple months ago at this point. And I was right in the middle of hacking on something, and there were deadlines, and life got away from me. And so I didn't actually look at it for a while after that. But I've done some updates, and there are some questions that I think it would be worth discussing. So some of the updates are really stupid things, like the document was referring to services.arpa, and it seemed like when we were doing the implementation, I had forgotten that it was services.arpa, and so I typed service.arpa, and it just seemed to make more sense. And so the document actually now says service.arpa instead of services.arpa because it's one less letter, and I don't see any real reason why it needs to be services.arpa, but if anybody objects to that, please let me know. And then the document now adds support for TLS. So if you want to do SRP updates over TLS, you can. And there's a registration for DNS SRP TLS.tcp. DNS name. So for SRV records. So that's already been added to the document. There are further updates needed to the document. So I'm going to just go over Tom's comments a bit. Tom, so the document was written by me as I was doing the implementation. And so of course I had a lot of state in my head, and it all made sense to me. Tom read the document, and he's like, whoa, this doesn't make any sense at all. And he had a really good point, which is that I use the term update. I think Stuart and I both worked on choosing the terminology for this section, and neither one of us really noticed that the update language was a little bit confusing. So I'm thinking that we need to change the name of the things that we're calling updates. Right now we have two things that are called updates: the actual SRP update message, which is the collection of all of the things that are to be updated, and also the individual DNS update RRs. And so what I'm proposing is that we either make sure that we always say SRP update when we mean the whole message, and we always say RR update when we mean the RR update, or we just call it an RR add instead of an RR update. I don't really have a strong feeling about that. Sometimes the problem with calling it an add is that it's not always an add. Sometimes there's already an RR there, and so it's really an update. But I think that's relatively harmless. Thoughts?
A word that comes to mind is register, because this is a registration protocol, and yet there's nothing in there that is a register.
So we could call the whole message an SRP registration instead of an SRP update. I like that. All right. Hopefully that will show up in the minutes. Otherwise, I'll probably forget. But thank you. That was a hint. Okay. And Tom also found the discussion of the whole validation section a bit confusing. I don't really have any questions about what to do there. I just didn't have time to do it before the cutoff. So I will do that when I next rev the draft, which will be soon. Tom asked some really good security questions. This is the first one. The question was, why are we not sending this? Why are we sending this in the clear? Why are we just making a TCP connection? And I hadn't even thought about it. So thank you for pointing that out. And as I said, I added TLS support to the document. My next question is, should we require TLS support? Should we not even offer the option of doing it over plain TCP? Anybody have an opinion about that?
Tim Wattenberg, yes.
You have an opinion about it? Okay.
I think if it goes off the LAN, it should be required.
All right.
But if you're going to do, something on the LAN like with UDP,
I don't think we have a way to do that test. And if we care about keeping the information, I mean, the thing is, this is a record that we're publishing, which will then be able to be looked up. So it's not like it's really a big, huge secret. So there is an argument to be made for it's really not that important. But Tim?
Relaying for Keith Moore, yes, require TCP always, even on LAN.
No.
I think he means
TCP or TLS?
I think he means TLS.
Oh, okay.
But yeah.
Okay.
TLS.
All right. Well, I'd say, from the perspective of voting, we've got a clear vote.
But who's going to sign the certificates if it's allowed?
Well, this would be opportunistic security, so it doesn't need to be signed certificates. We're already requiring it for DNS push, and the current implementation that I have for DNS push, does not check the cert. It just takes advantage of the if you have an on-path attacker, the on-path attacker will be able to intercept your connection and violate your privacy, but at least it makes it more expensive to do that.
Or you could do TOEFL security, like trust on first use, or.
Yeah, we'd have to describe how to do that. I think that it might make sense to describe how to do it with certificates, but if we did that, I'd kind of like to do it using Dane, and I'm not really ready to write that text, so that's why I'm punting. But if somebody wants to offer text, we can talk. So Tom brought up another security issue, which I think was a really good one that I hadn't thought about, which is that we currently are just asking for a global Anycast address. So if you send a message, a little backstory. There's two different ways that SRP works. One of them is that we require TCP for fully featured SRP clients. So the client is required to connect with TCP, and then we get a three-way handshake, and that means we know that we're actually talking to who we think we're talking to, and they're roughly where they claim to be. However, for IoT devices, requiring the full discovery process is kind of painful, and so I came up with a way to, on IoT networks only, support this global Anycast address update. And the idea there is basically the client doesn't do any service discovery at all. It just sends out an update and it says, "Hi, I'm offering this service. Here's the information. Good luck." And by the way, it uses a domain of service. Its DNS updates are to the service.arpa domain. That's where that comes in. And that's like really lightweight. And I'll tell you a little bit more about just how lightweight it is because it's kind of awesome. The point of that is that I just allocated a global address, and so now this IoT device is sending this update message. And if there isn't something sitting on path intercepting the message to the Anycast address, it's going to go out to the internet, right? It's just going to get routed somewhere onto the backbone and then eventually get dropped. But possibly not before some malefactor sniffs it and figures out that you have light switches in your house or something. And we'd like to avoid that. We don't want some malefactor to be able to sniff your traffic and know that there are light switches in your house.
And you just told us it's going to be TLS over TCP in the previous slide. Okay,
so two different scenarios here. One is the all singing, all dancing SRP update scenario. The other is the constrained device update scenario. So I'm talking now about the constrained device update scenario. In the constrained device update scenario, we're not doing TCP and we're not doing TLS, at least in principle. Maybe that's the wrong thing to do.
I think that you and I had some IMs yesterday or something about this document and the core resource discovery process.
Yeah.
And I don't think this is a useful feature based on what I now know in our discussion back and forth. I think that
when you say you don't think this is a useful feature, you mean?
I don't think that this is something that an IoT device which is sufficiently constrained that it can't do TCP and TLS should be doing on its own.
So
we have categories. I mean, 7228. Aside, because it doesn't actually give us, classes to describe the devices that are above it.
Mm-hmm.
But essentially, if you have enough energy to run Wi-Fi, then you have enough energy to run TCP.
But we're not,
TLS.
The use case for this is not that you have enough energy to run Wi-Fi.
Right. So what I'm trying to say is if you are that class of device, then I think you can fall into category A. Okay? Which is use TCP and TLS and the normal discovery that we do.
Sure.
Okay. If you are not at that level, then there is probably, there has to be some kind of a gateway just to get your data from, the internet that we all love to the network that you're doing.
Yes.
That device can do resource discovery from you in a energy efficient way and can do service discovery proxy to the rest of the network.
So there isn't a way to do that.
Okay. So what I'm saying is that gateway can be the thing that is translating between.
The purpose of this is to do service registration protocol from the edge device.
I understand that.
It is not to do service. It is not to do some kind of mapping between Core RD and service registration protocol.
Maybe I don't understand the space of things because I well enough, and but my feeling is that I think that the problem that you've created with the Anycast, and I remember we had the whole Anycast discussion. I think it wandered into 6-man and all this kind of stuff.
Yep.
And I'm actually quite upset that we don't have a good answer to the problem that you just have said. I think the answer is we need a ULA central address allocated so that it gets dropped correctly. Okay.
See the slide.
Yeah, that's right. Exactly. Okay, so I understand that. So I think that's the right answer to the problem. But before we do that, I'm not actually sure this is a problem we should solve, is what I'm trying to say, or that this working group should solve without more thinking and back and forth.
Stuart, do you want to step up to the mic?
This is something where I can give some more background. As many of you know, Apple has some home automation work with the HomeKit products. And right now they use Wi-Fi, which is good for AC connected products and not so good for battery powered products. And that this right now is a pet project of mine. I have been interested in looking at ways that we could make HomeKit more battery friendly. And that's why I've been attending the Thread group meetings. For those who don't know, Thread is something that came out of Google Nest. It's a mesh network led on top of 6LoWPAN, which runs over IEEE 802.15.4, which are 1/4 megabit wireless technology, similar speed and range and battery consumption to Bluetooth, but has the benefit of being more IP friendly, which is why I'm predisposed to like that. And then I've been going through this little thought process of, if we wanted to run HomeKit on Thread, what would we need? We don't necessarily need a gateway to the greater internet. I could imagine just a self-contained Thread mesh that doesn't even connect to my home Wi-Fi, but it allows light switches to control lights via IP packets on that mesh. In order for that to be done with the HomeKit protocols, the light switches have to discover the lights that they're turning on and off. And HomeKit doesn't use Core RD. HomeKit uses DNS service discovery. So this leads us to the question, if we were to build HomeKit devices that are battery powered running on 802.15.4, how would we provide the facilities that they need? And that leads us to this work, which is, how would you do DNS service discovery without resorting to just flooding multicast everywhere and running the batteries down?
Right. So that's a motivation for doing this work. And essentially what we're offering here is just, here's a lightweight way to do this thing on an 802.15.4 network or something like that. And you know, it's not a huge change to the whole protocol. In fact, it's essentially the exact same thing, except that you're not going out and looking up the SRV record. You're just sending it to some well-known address. So you know, one option is certainly to say, no, you can't do that. That would be kind of a weird thing to say. But certainly the working group could say that. Another thing to say is, sure, go ahead and do that, but you need to use a site scoped any cast address, in which case we have to go out and solve that problem, which is kind of heavyweight. Or we can just make it something where it's not specified how what address is used, but just generally speaking, if you want to use this lightweight mode, then whatever IoT or constrained network you're using it on is going to need to have a well-defined address to which these packets are sent. So, you know, I don't know what to say about the whole Core RD versus Dnssd thing. That's really not, I'm just not even interested in Core RD. So maybe I would be at some point in the future, but I'm not right now. So I'm just interested in solving this particular problem. And the question is whether there's, you know, whether it's something we should in fact solve. Personally, I think it is. I think it's useful. I mean, whether you think Core RD is a good idea or not, I think it is useful to be able to announce the presence of a device and register it as a service in Dnssd. So
Michael Richards again. I'm not as terribly clued into what Thread is doing, and it's very hard to know without going to the meetings and paying the large amounts of money. If you'd like to bring me, I'm very happy to go there.
Noted.
But I am working with Thread on enrollment things, and they do a lot of things differently just for the hell of doing it differently. So if I were to learn that they actually have a service discovery protocol, you know, already, I'm almost certain of that is the fact. So if you were to make HomeKit work under Thread, you would either have to convince them to run this or do something else. Okay, so I think it's not entirely a particularly important consideration. The point is that whatever, I don't think it matters whether they're running SRP or they're running something else or Core RD. The point I'm trying to say is that if there's going to be, if it's going to matter to devices outside of that network, then there's a gateway that is mediating that process. Okay. Yep. So I think that we could have that happen, and I think that would be better. Having said that, I'm not opposed to you going forward.
Okay.
Okay. I think that if you don't want to go through the rigmarole of trying to find us a site scoped address anycast that's going to leak that's going to be secure when it leaks, right? Then I think you should defer the work until we do that. Okay?
Yep.
This part of it.
Yeah.
Having said that, I think we should get the site scope, any past thing worked out. But it's, as you say, it's going to be at least an hour and a half conversation in 3 different 6-man meetings before we can have this happen.
Right. Yeah.
So, but maybe that's worthwhile.
Yeah. So basically, the status quo now is that we're currently using a global address, and Tom pointed out that that's a bad idea, and I agree with him. And so I think that the expedient fallback, and the one that probably makes the most sense, is to just consider the use case that we actually have in mind and think about what would work there. And the answer is a mesh local ULA, a well-known address within the mesh local ULA. Stuart?
Yeah, Michael, you asked some interesting questions. So I'll briefly answer them because we had similar questions when I started getting involved with this. You might assume that the thread group has a discovery protocol defined. They actually don't at all. The way thread discovery, in quotes, works today with the Nest thermostats and the smoke detectors is that everything phones home to the cloud. And the quote discovery is which devices are owned by the same Nest account in the cloud. There is no local peer-to-peer discovery. It's all mediated through the cloud. So that was a disappointment because we were hoping to find something a little bit more fully baked. With Apple's different priorities, the HomeKit is built without a cloud service. It assumes you've got some brains in the house and nothing has to leave the house. So things need to discover other peers on the network. So that is how we went down this path, which is Thread has no discovery mechanism currently defined. They need to define one to grow beyond their current limited use cases. And naturally, this is what we're advocating. So that's how now, the feedback about the details here is incredibly valuable. I agree that any address that might escape the house by accident definitely is not what we want to risk for privacy reasons. So maybe for the thread case, the answer is that the thread local network data conveys a configured address to the clients and they use that. So for the thread case, I think we can solve this. For broader use cases, this might still be an interesting discussion to figure out how to automate it for all link types.
Christian Amsus, I think that we have the RD and the Dnssd discoveries have their dissimilarities, but when it comes to the Anycast address and having an ARPA domain for all those site local things, I think we should sit down together and kind of compare notes on what we can unify and where we have separate ecosystems.
Yeah, definitely. Yeah, it's a separate conversation, but yeah, that's definitely worth doing. All right, so moving right along, I think that the conclusion that I'm drawing from this is that I should just say that we should use a mesh local address and that this document, that's out of scope for this document, but generally speaking, this is what we suggest. So Tom also pointed out something, and Stuart, I haven't actually had a chance to talk with you about this, so I apologize for springing it on you on a slide, but here it is anyway. Tom pointed out that sleep proxy is not entirely compatible with what we're doing for SRP because SRP doesn't necessarily assume that the thing we're updating is on the local wire. And he was confused by that, and I think it may mean that we basically, so SRP is a router unicast protocol. The DNS server does not have to be on the local wire. Sleep proxy requires a presence on link. Sleep proxy is essentially doing the same thing as SRP, and that's why SRP and sleep proxy are in the same document, but it's not doing entirely the same thing because we have to support the wake on LAN feature. So we need to figure out whether the right thing to do is have a sleep proxy document or to make things sufficiently clear that it doesn't trigger Tom. Which, I mean, with all due respect, I'm not saying that you shouldn't have been triggered. You should have, but we need to make sure that it's clear enough that when you read it, you're like, oh, okay, not what the. So does anybody have opinions on which path we should take on this?
Michael Richardson again. I would say if it enhances this document and makes it more applicable and makes it easier for developers, then you should probably keep it in the document. The IESG seems to want us to have fewer documents. So if the motivation for sleep proxy, if the sleep proxy has an existence or motivation which could be deployed without this document, I don't think that's true, but if that was the case, then I would say, okay, maybe it makes sense a separate document.
Yep.
If for some reason the document was monstrously too big, and you have had the comment about too big documents are impossible to review in advance, then I would say it's something to remove, but I don't think that's the case.
Yeah, I don't think it is.
So I think it's maybe it doesn't really gel with the rest of the concept, but I think it fits into the space.
Yeah. The thing that we really want to add, so sleep proxy already exists. Like if you have any Apple products, they already have sleep proxy built into them. But what we wanted to add to that was first come, first served naming. And so really, if you could think of this as just 3 separate use cases for the general SRP registration update. One of them is registering to an SRP server that's serving possibly a multi-subnet LAN. One of them is registering your IoT device that's on a constrained network. And the third is registering with a sleep proxy. And a sleep proxy is not an SRP server in the same sense. So essentially, I think maybe that's a way to explain this that is less confusing. Does that make sense to you, Tom? Okay. So in other words, SRP updates are the same for all use cases. However, SRP updates to there are 3 different things you might send an SRP registration to. Changing the terminology. You might send an SRP registration to a DNS server, an authoritative DNS server, to have it add that to its database. You might send it to your what are we calling these things? Your border router, your constrained network border router, or you might send it to your sleep proxy. 3 different recipients of the same type of message that has the same essential features. And the way that they're handled are slightly different, but they basically all have more in common than is different about them. Tim, did you want to?
Yeah, Tim Wattenberg. I agree with what has been said before. So I think it would be better to have this stuff in one document, but like clearly separated in their differences, because too many documents don't make it better after all.
Right. Yeah, we did go down that path for a while in the IETF, and it was exciting. So if the note taker could explicitly note that we're going to have these 3 different use cases for the awesome. Oh, thank you. Much appreciated. All right. So now that we're done with the boring stuff, I've done an implementation of the SRP client that actually I have running on a thread board as it happens, and it's pretty sweet. It's all the code is less than 10K, including key generation and 6.0 signing. It's really simple. It just adds 1 service, and the message that it sends to the server is about 320 bytes. So it's very compact and efficient for what it does, I think, and does seem to work. Tim,
I might add a little to Wattenberg. So I think I wrote something like this on last year's hackathon here in Montreal as well.
Yeah, you did.
So I might dig it out and post it somewhere where people can see it. But it was also pretty simple, 1 service, but it used the protocol.
Now, did yours do the 6.0 part?
I'm not sure. I have to look back into it. Maybe it didn't.
Yeah, when I looked at the code that you had, it didn't have 6.0, but I don't know if I was looking at the final version.
Yeah. I'll dig it out again and send it to the list.
All right. Yeah. If you need any help with 6.0 stuff, let me know. Okay. So that's the client side. I've also implemented an SRP proxy, yet another proxy, right? So I wanted to be able to have to receive actual SRP registrations on port 53 and have them update an authoritative DNS server. But I looked at doing that to bind 9, and it was actually a fairly big job. I think it's doable, and I'm talking to Mark Andrews about that. But I wanted something that was not, basically I wanted something generic that could be put in front of any authoritative server that accepts DNS updates. And so I wrote some code that does that. And so what the code does is it receives the SRP registration, and then it figures out what DNS updates it has to do. Now, the idea with an SRP registration is that the whole thing fits into one message, because it's all of the records are pointing at each other, and there are no prerequisites. DNS update allows you to use prerequisites to prevent data from being added to the zone that you don't want to add to the zone, and it allows you to do a sort of it allows you to do an atomic update of the database where, if these prerequisites are true, then do the update, and don't change the database in between checking the prerequisites and doing the update. SRP there's no way to do a single message SRP update with prerequisites, because there are too many different things, and DNS update prerequisites don't allow you to do things like if then else. So what I've done instead so the proxy is receiving a single message, and then first it just tries to do the update straight and sets the prerequisites. If nothing's there, do the update. And if that succeeds, great, we just did it. If that fails, or actually, first it does no change. So the assumption is that the record is already there. We're going to send an update, and the prerequisites are that the record is there and contains the same information as before. And that can happen in one message. If there's nothing there, then that can happen in one message, but that would be a second message. And then the third thing that happens is neither one of those attempts worked, and that means that there's something there, but it's not the same as what's in the SRP registration. So now we have to actually go through and iterate. And so it's this complicated state machine that just goes through and does all of the iterations, adds or updates various records. And if it comes to a situation where it realizes that there's something in the zone that conflicts with the SRP registration, then it has to back everything out and send a failure response. And on the other hand, if it gets all the way to the end and doesn't have any problem, then that was success, and it sends a success result. I think I've exhaustively tested all of the various different ways that it can succeed or fail, and they all seem to work. So it's pretty sweet. It's actually kind of fun to watch, because you see like one SRP update come in, and then like a bunch of events occur in the log. That was fun. Future work. HomeNet integration. We were talking about this on the HomeNet mailing list, actually. HNCP identifies links. It would be nice if the Dnssd discovery proxy, that was 3 implementations ago, if the discovery proxy could take advantage of the information that HNCP is sharing. Packages for OpenWRT, we already have them, but there's still some work to be done so that you can just install them and it just works without you having to fiddle around with it, which currently there's a README file that has a fair number of instructions in it. So that's one bit of future work that we want to do. Another bit of future work is a fully featured SRP client, similar to what Tim did, except possibly we don't know whether he did SIG0 or not. So that would be really cool. And it sounds like it's going to have to support TLS also. And I don't think that's a big amount of work, but it needs to happen. It would be nice to have SRP support in some DNS auth server, and I'm thinking Bind9. Mark Andrews, as I said, has talked to me about some work that he's been doing to make Bind9 support a wider variety of different kinds of update strategies, and it would be kind of cool to add this in as another update strategy. Mark has indicated a willingness to collaborate with me to some extent on this, although presumably I have to do most of the work. So I'm hoping that this will happen before Singapore, but I make no promises. SRP relay. If we wind up having a link local anycast address for the simple, the IoT style SRP update, it'd be awfully nice to have a relay that sits on the border router that's pretty stupid and just relays it to the actual SRP server, rather than having to have an SRP server on the border router. So that's my list of future work. I'm not promising that any of these things will be done at any particular time, but they are definitely on the agenda. And if anybody's interested in hacking on any of this stuff, please let me know. And also, if you're interested in just like playing around with the stuff that I've already got, please let me know. There will be some information on the next slide about that. SRP, the future of SRP. So SRP got one review during last call. Thank you, Tom. And the chairs were really mean and decided that that wasn't enough. And so, complain. So it turned out that we talked about this in the HomeNet meeting on Tuesday, and everybody there seemed to think this was useful. And so it seems like we really could have gotten enough comments to make this work look like it was like it had support, but we didn't, because we didn't actually ask HomeNet to comment on it. So we're going to do that hopefully in another last call. So hopefully that'll mean that we don't drop this and it gets published as an RFC. So my proposal is I'm going to update the document, add in the stuff that we've talked about. We'll do another review and try to include HomeNet and maybe DNSOP, although that could be dangerous. And hopefully that will result in us being able to publish this. So that's all I got. Tom?
Tom Pusteri. So there's one comment I made that you didn't address that I think it should be addressed in the document, and that's it. How do you delete a registration before the lease lifetime expires? And you may not want to do that, but there's no currently a way to do that.
Yeah, sorry, thank you. I spaced out on that, and that's a really good point. So in other words, we want, in addition to an SRP registration, we want an SRP deregistration. Yeah?
Or maybe you don't, maybe.
So Dnssd over MDNS currently does do that, right? If you have a device that is sending out an or has sent out an advertisement to somebody that it's on the network, when you shut it down, if it's able to send out a goodbye packet, it does. And I think this is the equivalent of that goodbye packet, and I agree that that's worth doing. It's just an omission. So thank you for pointing that out.
And then the other thing is, if there's anything that you learned extending update, it would be interesting, I think, to incorporate these into a new version of update that other applications can benefit from. Mm-hmm. And then maybe one day this can migrate to update, to the new version of update.
Yeah, I mean, if we had it all to do over again, I mean, when I first started working on this, I was thinking, do we really want to do this in a DNS packet? I wound up doing it in a DNS packet because it's just expedient. It's less work. There's already stuff out there that accepts DNS updates, and so I was able to test it very easily, and it's all very straightforward. If we really wanted to do DNS updates right, we would probably just have, a DOE thing that does DNS updates and has like a more
like a post. Like a post.
Yeah, well, yeah, I mean, sure, but mainly that has like a more rich prerequisites language, so that we can do a single update, an atomic update to the database that adds everything at once and checks all the prerequisites at once, and so we don't have the situation where I have to go in, add things, back out. The worst case scenario is I add things, then I back out, but something else stumbled over something that I added in the process, and it backed out, and now everybody's unhappy. We really want it to be atomic, but there isn't a way to do that unless it's happening on the server.
The first come, first serve stuff comes to mind as something that regular update could benefit from as well.
Yeah, yep, for sure. Yeah, and actually, I think Mark would be down with adding that to Bind 9. So anyway, any other questions? Should we move on to fate of the working group?
Thanks, Ted. All right, so our last agenda item, which can cover all the time we have left, which is until 3:30, so 40 minutes, is about the future of the working group. So Tom, what?
Sorry. Michael's typing stuff that I already have in the notes below where he's typing.
Okay. So Tom brought this up on the list, so thanks, Tom, that we don't have that much feedback on some of our latest documents. And we were wondering, so kind of where do we go from here? We were considering for a while rechartering this working group. And one of the main topics that we were considering for the new charter was the privacy work. That said, so that is still a possible viable path forward, but similarly, it doesn't feel like there's a huge amount of energy going into the privacy work. And so one option, which I'm not saying I'm recommending any of these, but one that has been suggested is to move that work somewhere else and close this working group. So I wanted to hear feedback from anyone in the working group of what are your thoughts on this question? What should we be doing? I'm looking for feedback from all of our authors, but also from everyone else in the community.
Stuart Cheshire again. I want to echo what David is saying. From a personal standpoint, I think privacy is really important. And I think in the last year, there's been a lot more awareness of how important privacy is. And I think that's only going to continue. I've thought about these questions of how to do discovery in a privacy preserving way a lot, and I don't know the answers. So I think it's important, but I don't know how to do it. If there are other people in the working group with good ideas and there's energy for doing this, I would love to support that. I think it would be sad if we wrap up the working group just as the whole world suddenly wakes up to the importance of privacy. That would be unfortunate timing. So I hope we can find a way to move forward. Unfortunately, I've spent a lot of time thinking about this, and I have not worked out any wonderful answer that just solves all the problems and is also efficient and reliable at the same time.
Thank you, Stuart.
Ted Lemon. So I attended a side meeting yesterday, the MedUp side meeting. This is a group that's been meeting sort of associated with the IETF, but hasn't really pushed to actually form a working group here. And they are interested in this topic. It might be good to try to get some of the people that show up for those meetings circled in on this whole DNS discovery privacy thing.
Can I ask you to elaborate on what that group is about?
So they're MedUp. What do they call it? Distributed something privacy. Sorry. No. No, not deep red. Distributor. So basically, it's ad hoc privacy. So basically, the same problem that we're talking about.
That sounds related.
Yeah,
it does sound related.
Really does sound related. They're working. The work that was presented there this time was all about coming up with basically doing ad hoc keying. So some work that Daniel Kahn Gilmore has been doing with a bunch of other people on coming up with ways to do encrypted email that doesn't suck, that has a good user experience, which means it's less secure, but it's better than nothing, right? So that's interesting and kind of not what we're talking about. There was another group that was doing something similar with instant messaging. I think that the work that we're doing isn't exactly the same as the work that they're doing, but it's synergetic with it. Like they could take advantage of what we're trying to do, and they would probably be interested in what we're trying to do, and they probably know something about the problem space and might be interested in working on the problems that we're working on too. So that's why I say that they would be good people to talk to. I think that even though they haven't actually gone down the path that we've gone down, I think if we said, hey, what do you think about this? They'd all be like, ooh, that sounds good. So.
Thanks.
Christian Wiedemann. Well, I've been trying for some years to get privacy work to actually start into this working group, and I've come to the conclusion that it's not going to happen because, we have been going through various things. Now, I think that we did a number of things that should be somehow published. And I think I will need to find a way in particular to publish the privacy requirement documents that we had. because there's an analysis there that could inspire other solutions. But as for the studying of solution, I think that they will have to come organically from the other groups that are doing any kind of discovery.
Thanks, Christian. And that makes sense to me. If we were to try to move the privacy requirements document to publication, could I have a show of hands on who would be willing to read that document and comment on it? Thanks. Okay, so I think we can try that. You're one of the authors, right, Christian, on that one?
Yeah, I mean, given the general level of energy on the project, I mean, that thing expired, but I mean, I could easily run a new version to, reiterate the draft.
Yeah, no, if you want to revive it and then email the list for comments, I think moving it forward and publishing all of because that's true, a lot of thought and work has gone in this working group on developing these requirements. I think regardless of whether we come up with a solution or not, I think publishing the requirements is a reasonable thing. So, thanks.
So I'm Michael McCool from Intel, and I'm also co-chair of the Web of Things working group in W3C. And my interest in this is we are trying to distribute information about devices, but we want to do it in a privacy-preserving way. In fact, it's one of our requirements to get recommendation status in W3C. But we fundamentally need a discovery service to control distribution of metadata, and especially in the home context and also the smart city context. And so this is kind of a fundamental requirement for what we want to accomplish, and we feel for ecosystem adoption. So the real question is, where does that work belong, right? So should it be an extension of DNS? There's also work over in core on the core resource directory, right? And so, in my opinion, there's really two problems. One is the service provides the metadata, and there's the question of how you find that service, right? And in some cases, I see these functionalities merged together, but I really think there should be two separate phases with authentication in between. Because really what you do is get authenticated information to data. And so I noticed earlier someone was saying, well, if it's published, then everyone knows about it, it's not secret anymore. But actually, even like an address that has a name like temperature sensor dot local is a leak of information about what's available. So I think it's extremely important, but I think we need to think very hard about where it belongs. Maybe it shouldn't be in this group because maybe it shouldn't be DNS based. Maybe it should be a new thing. Maybe DNS should only be the springboard for the initial introduction to a controlled service. So I think maybe we need to think of this at a higher level and think really hard about where it belongs and how a group should be chartered to do a privacy-preserving discovery service.
That's definitely a possibility. Thank you.
Tim Wattenberg. So I think this working group does valuable work, and we're not finished with this. So closing it down right now would just doesn't make sense in my view. I think we have a problem with the lack of participation, at least on the discussion on the mailing list. I mean, today I think we got a good discussion here on the things we brought up on the agenda, but that's I guess the problem. And the question is, how can we get more people, maybe also from different angles and doing different stuff to notice and also comment on the work which is done here. And I guess after all, so of course not speaking for him, but I think Tom didn't actually wanted the working group to shut down, but just to give a wake-up call on that. That would be my guess, because otherwise I don't know if he would be sitting here. So I think, it's once again a good call to just see if we can get people interested in what we're doing here. Maybe they don't even know that there would be something which would be interesting for them, which they could use. The question I cannot answer is how to get these people here, and maybe some more experienced IETF community people have a better idea, but I don't know.
Eric Vink here with my AD hat on. So indeed, the lack of interaction about the privacy is kind of concerning. happy to see that 5 people are happy to review it. So that will be a good sign. Now, typically in this kind of document, you will not find the privacy people in this room, but in other rooms. The document can stay here, but making some publicity of this document in other working group, like Brian will do on Deprive in a couple of minutes, is good. So it's up to you, Chair, as well, to make some publicity outside.
So we have tried that in the past IETFs, starting I think actually in Montreal a year ago, and didn't get that much support from like other people in this community, or sorry, in the IETF community at large, to come to this working group. Perhaps one of the reasons is that they care about privacy, but maybe not in this specific context. Then I'm speculating at that point. But
it wasn't a try.
Very true. Agreed.
We're in sync.
Michael Richardson. So I'll point out that SAG is happening right now.
Sorry, say again?
The SAG working group, the security area working group is right now. We're in conflict with it. Okay. So, more empty chairs than full. All the people you wanted, most of them are, unless they came here, because they, I probably would have gone there, but I thought this was interesting. I was unaware. I did read Christian's documents. I have a vision of actually thinking about it in my old office, which I haven't been to in 2 years. So, it was at least that long ago. I was unaware. I just assumed they'd gone to working group last call and gone out. I was unaware that they were stalled. Okay. So I would support the comment that, yeah, the working group is having difficulties. But I don't think it's time to give up at this point. And let's get SRP published. There's only so many cycles for everybody in the whole thing. I don't think we're certainly not done. And I would encourage Christian to take up the pen again as well.
And so I think one thing that we were probably supposed to do, probably me, was to take Tom's charter discussions that are in the GitHub and start forwarding them around to the group to look into potential rechartering language to explicitly support the privacy efforts here. So I need to do that.
So, Ted Lemon, a couple things. One, just to reflect back again what what Mike said. Michael. Anyway, sorry. I have several times missed the TLS working group because it was opposite Dnssd. So again, the likelihood of us actually getting the really deeply committed privacy people in this room, if we're opposite any SEC area meeting, is 0. And so we have to have a hard, if we're serious about doing this work, and if this is the working group to be doing it in, we have to have a hard requirement that we have conflicts with TLS, SAG, Deprive, pretty much any working group that's doing anything that's related to privacy.
And I absolutely agree, and that's what we put into the data tracker. But at the end of the day, I don't think there's any single slot at IETF that doesn't conflict with some security meeting.
Yeah. So maybe that's a good thing in a sense. So
yeah.
So anyway, the other thing to point out is that this doesn't have to happen at IETF meetings. So one of the things we can do, and I think I might take this as an action item, is to actually present something about this, unless one of the authors wants to at the next HOT RFC, so that there's just a little bit more visibility and people actually join the mailing list and start discussing this with us. As far as the energy to work on the document, again, what Michael was saying is totally applicable to my experience as well. I reviewed all of the documents. I sent substantial comments on them. And then the work I stopped seeing new versions of the document. So it's not because I'm not interested in the document. And I'm not saying this to blame anybody, because I've done the exact same thing, right? Like, I've been busy working on implementations of all of this stuff, and I haven't actually updated my documents as frequently as might have been desired. So I think that we have a lot of, I think we have a lot of expertise in this room that's related to the problem space that we're talking about, and it would be a shame to disband that expertise. However, I think that the clock rate of this working group is not 3 times a year. And part of the reason why it appears that there isn't energy to work is that we're just not working that fast. It's not that we're not working. It's not that we're not making progress. It's just that we're not making progress on a pulse rate of every 4 months. So I think that mere fact is not a reason to disband the working group.
Thanks. That makes sense. And one of the things we discussed actually is that we don't necessarily have that much to talk about every 4 months. So one potential option would be that for one of the next IETFs, either we don't meet in person or we meet jointly with another working group.
Which on Tuesday morning, the HomeNet people who did meet actually suggested that it would be really useful if we could maybe just do a joint session with Dnssd and maybe have a 2-hour session like we have here and have 30 minutes for HomeNet or so.
Yeah, that sounds reasonable. Stuart?
Yeah, I like those suggestions. I like what I've been hearing. I think Eric's right. We, all of us, not just the chairs, need to figure out how to publicize this. I agree with what Ted said, that giving a hot RFC talk is a great opportunity on Sunday night to introduce people. And you said you already listed the security areas as a conflict, which is good. Let's, if we decide to continue for next time, let's try to stress that more with the IESG, because what I say about the work of this working group evolving is we have solved some of the initial challenges of less reliance on multicast and more reliable discovery. And now really the remaining goal we have is this privacy work. So we've almost shifted from being a DNS working group into a security area working group. And people outside this group have no way of knowing that if we don't tell them.
True. Thanks. Tom, could I ask you to share your thoughts since you sparked this discussion on the mailing list?
Yeah, so I think my email was in response to the last call, working group last call of those 2 documents, which were, the main focus of the work of this working group. And having been the only one who reviewed one of them and no one reviewed the other, I was pretty discouraged. And it doesn't, if you think they're good, then it doesn't take a lot of work to say, I think it's good, right? That's all we needed, but we got nothing. And so that made me think, well, who are we doing this for? And then it made me think about, well, initially we had a group of people who came to us and said they had a problem to be solved, and we solved it, and those people are gone. Are they deploying this? Do they have any intention to deploy it? Are they asking their vendors to implement it so they can deploy it? And those are the questions that I think we need to answer. And I think they're still unanswered.
Thanks. And I guess, so this, from limited experience, I suspect like those are markets that don't maybe evolve as crazy quickly as other working groups. So to Ted's earlier comment, maybe giving them time is what's needed here.
Ted Lemon again. Yeah, just one thing to say about the adoption rate is that if nobody's using, if there isn't a device that can consume some of the stuff that we've designed here, then there's no point in deploying that functionality on your network. Once there is a device that can consume that, then suddenly it becomes more worthwhile. So it'll be interesting to see if there's additional uptake now that we actually have DNS push in iOS and macOS next generation.
And actually, because that's a very good point, that's maybe not obvious to everyone. Could someone from that makes handheld devices comment on what's currently supported and what's been added recently?
Yeah, Ted actually mentioned this on this slide, but I agree it's worth highlighting it. Ted has been working initially as a contractor, and now we're moving to hiring him full time. Ted has been working at Apple, implementing this work in macOS and iOS. And I'm not leaking any secrets there because this is in the public betas. So if you install iOS 13 or macOS Catalina, then you have a fully functioning push notification client, and it will connect to the discovery proxy that we have running on OpenWRT. And it's very pleasing for me to be able to turn services on and off and see them update live on my iPhone and see that it's all working as it should.
One thing I forgot to mention is when we were off designing this protocol and like the discovery proxy that Stuart Muesli designed, the router and switch vendors were coming up with alternate solutions by listening for broadcasts, multicasts on one network and sending them to another. And they've kind of went ahead and solved the problem in the switches and in the routers and stuff in a non-optimal way. But those solutions are deployed today on campuses. And so we have to have some sort of compelling reason for them to stop doing that and start doing this.
Michael Richardson, a question. I think this is an implementation-ish question. Will I discover devices at my home when I'm connected to it over a VPN? Yes. Okay, wonderful. That is actually a really, kind of killer app.
Yeah, when I was demoing this at Apple before all of the releasing occurred, I used that feature and it was really awesome. I did a printout over the internet from California. My printer was at home and I had an IoT camera pointing at it. And I printed to it and a little page came out and everybody was all excited. So it's very cool. I just wanted to mention to Tom's point that yes, there are a lot of implementations of various hacks that purport to make multicast DNS work on multiple links. And our experience with them is that frequently they don't work at all. Sometimes they tease you by working a little bit and then failing. I've never seen one that actually works. So.
Yeah, I just want to expand a little bit on the funny story that Ted told. He did a demo for the guy in charge of our department, and you wouldn't think it would make any difference because you could have a diagram on a slide with boxes and arrows and things and saying the packets go here and this happens, but there's something about the showmanship. So Ted had the live video on the screen of the little camera pointed at his printer at home, and he tapped AirPrint on his phone, and we could see the piece of paper come out, and the whole room erupted in applause. It was amazing.
So maybe what we need more here is Apple marketing. Okay, so it feels to me like there is some pretty good consensus in the room that there is still energy to do work and get documents published. Maybe not as a crazy fast rate, but that's okay. So my sense is to keep this working group open, keep the mailing list open, and then maybe we'll have a shorter meeting in Singapore. We'll see by the time we get there how many, joint with HomeNet. It'll depend on what we get on the agenda. So to our authors, please don't wait till the day before the meeting to send us your agenda items. That would be particularly helpful in scheduling us this time for how much time we want to have. Do you have anything else to add? Okay.
You said it all.
All right, then we'll wrap up.
Is there anyone else? Anyone else have anything they want to mention?
I really don't want to prolong this. This is Ted again, but what I actually think is going to wind up on the agenda for Singapore is a presentation about how we're using this stuff in HomeNet. So it will actually not really be a HomeNet thing or a Dnssd thing, but a both thing.
How fitting. Has anyone not signed the blue sheets?
Which are there by Ted.
Yeah. And so to wrap up, I think we got a good information about the two upcoming documents, the ones that are almost published. So we're gonna discuss those more on the list, and hopefully with that renewed energy, we're gonna get them published, which is great. And then Christian's gonna revive the privacy requirements document. So hopefully we'll actually see you on the list and not just in Singapore. And hope to see you soon there. Thanks for coming.
And thank you to our note takers, Michael and Christian number 2 or 1, not sure which order to put you in. And to Tim for Jabber.
Be out of a job.
Nope, you still have a job.
Yeah, I thought I was going to be out of a job. Yeah.
Many of them, so we need to remove one. I mean, but of course, it's.
Well, that's the thing. We're both involved.
Which is of course the priority. Next time there will be meeting groups like chairman.
Oh, they're changing that? Oh, okay.
Actually, changing just a little. 21 is 23.
Oh, I see.
Now 51 is chairman.
Because I just put everything in priority 1.
Yeah,
I mean, it's like the SCP. All my packets are important.
So,